Okay, let's start. Today is gonna be class 20. Okay, so I'm gonna starting with the five main equation that we talked yesterday. Okay, yesterday I explained these five equation. We have a demand for good and service equation, Fisher equation, Philip curve equation, adaptive expectation equation, and monetary policy rules equation. Okay. And after we have five main equation, we're gonna mix it up. Okay. So today we're gonna use this five equation to find the dynamic aggregate supply equation. It is the first thing we're gonna do today. In order to find the dynamic aggregate supply equation, we're gonna bring equation 3 here, which is pi t equal to expected t minus 1 pi t plus phi yt minus yt bar plus vt. And then I'm going to bring equation 4 here. Equation 4 is expected t pi t plus 1 equal to pi t. Okay. And then equation 4, we're going to use the trick. Okay. We're going to backward equation 4, one period. Okay. Backward one period, which means in the equation expected t, backward one period become expected t minus 1. Pi t plus 1, backward one period become pi t. Pi t, backward one period become pi t minus 1. Okay. We backward one period the whole equation. And then you're going to notice that this is expected t minus 1 pi t, expected t minus 1 pi t. This is actually the same, right? So we can plug it in equation 3 easily. Then after we plug it in, we're going to get dynamic aggregate supply equation, which is equal to pi t equal to pi t minus 1 plus c yt minus yt bar plus Vt. Okay, this is dynamic aggregate supply equation. Let's come from combine equation 3 and equation 4 together. I'm gonna copy this one. Okay. From this equation, we can simply drawing the graph. Okay. Here, the graph of dynamic model on the horizontal is gonna be y, on the vertical is gonna be pi. Okay. Pi for inflation. Okay. In order to draw the graph, we're gonna look at the relationship between the vertical and the horizontal. The horizontal is yt. The vertical is pi t. Okay. So as you can see, if from the equation, if yt increasing, the right hand side increasing, right? The left hand side gonna be increasing too. So pi t or inflation also increasing, moving in the same way. On the opposite way, if yt going down, pi t also going down. They have the positive relationship. Okay, we have the positive relationship between inflation and y. Y in this case is for supply, total supply. Y in this case means total output. We can use this to draw the graph. We're gonna have the positive slope of dynamic aggregate supply like this. Okay, we're gonna see that dynamic aggregate supply always has a positive slope, and is the meaning is actually the same with the law of supply. Okay, for example, point A, if inflation is low, pi 1, everything is cheap, right? For the business sector, they're gonna produce less, pi 1. They're gonna produce less. From A to B, if inflation is high, which means everything is expensive. For the business sector, they love to produce more, right? It's simply law of supply. Okay, this is how DAS graph come from the equation. Next one, I copy the equation, I paste it here. Okay, next one, we're gonna see the factor that can shift the dynamic aggregate supply. Okay, we have y on horizontal, we have pi on vertical, we have dynamic aggregate supply, DAS1, let's say. We have point A, for example, here. Inflation, pi 1, GDP, y1. Okay, we're gonna fix the level of total output here, and we're gonna see how inflation gonna change. Okay, so the effect that can shift the dynamic aggregate supply is gonna be pi t minus 1 and Vt, supply shock. If pi t minus 1 increasing, okay, yesterday inflation is high, or we have a positive supply shock. Positive supply shock is mean that we have some external factor that make the cost of production become higher. For example, we have a war in the Middle East, oil price increasing, right? Everything, the cost of production become expensive, right? Okay. All of this is going to make the right-hand side of the equation become higher. Then the left-hand side is going to be higher, which means everything is going to be more expensive today. Okay. Pi t increasing, which gonna shift the dynamic aggregate supply up from A to B. Inflation increasing from pi 1 to pi 2. On the other hand, if inflation yesterday going down, or we have a negative supply shock. Negative supply shock is mean that we have some external factor that make the cost of production become lower, like we have a new technology, for example. Or this is going to make the right-hand side of the equation going down. Then the left-hand side is going to be going down too, which means everything becomes cheaper. Inflation becomes lower. So in this case, dynamic aggregate supply shift down, okay, from A to C. Inflation going down from pi 1 to pi 3. Okay. Like this. Okay. So this is a case of shift the dynamic aggregate supply curve. Okay. Done with the dynamic aggregate supply. It's all done. Then we move to the next page. Now we're going to talk about dynamic aggregate demand, or DAD. Okay. We're going to bring three equations here, starting with equation 1. Okay. The demand for good and service, YT equal to YT bar minus alpha RT minus rho plus epsilon T. I'm going to bring equation 2 here. The Fisher equation, RT equal to IT minus expected T pi T plus 1. And then I'm going to bring equation 3 here, adaptive expectation. Expected T pi T plus 1 equal to pi T. Then focus on equation 2 and equation 3. They have the same terms. Expected T pi T plus 1. I can simply plug equation 3 inside equation 2. Then what I'm going to have? I'm going to have RT equal to IT minus pi T. Okay. And after that, you can look at equation 1. Equation 1, I have RT. Here, I also have RT. I can simply plug the equation of RT inside equation 1. Then what I'm going to have is, I'm going to have YT equal to YT bar minus alpha IT minus pi T minus rho and plus epsilon T. Simple like that. And after that, I'm going to bring equation 5 here. The monetary policy rules. IT equal to pi T minus rho plus theta pi T minus pi T star plus theta Y, YT minus YT bar. Okay. And then as you can see, we have a nominal interest rate in the equation, IT over here. Nominal interest rate, IT here. I can simply plug equation 5 inside this equation, right? Then what I'm gonna have is yt equal to yt bar minus alpha, big bracket, pi t minus rho plus theta pi, pi t minus pi t star plus theta y, yt minus yt bar, minus pi t minus rho, close the bracket, plus epsilon t. Okay, pretty long, right? And then you can see that, wait a minute, I think, oh, this one is positive. Yeah. Okay. So you can see that here, pi t in the front minus pi t in the back cancel out. Rho in the front minus rho in the back cancel out. Okay. So then it's gonna be the equation is gonna be reduced to yt equal to yt bar minus alpha. Okay. You can multiply alpha into the bracket, become alpha theta pi, pi t minus pi t star minus alpha theta y, yt minus yt bar, plus epsilon t. This is what you have. Next one is you have yt on the left. We're gonna bring all of y to the left together. Okay, bring everything about y to the left. So then you're gonna get yt minus yt bar, close the bracket, plus alpha theta y, yt minus yt bar. The rest is the same. Okay. Then you will see that the equation on the left, you have the same bracket here. It's a common terms. You can take it out. Then you get 1 plus alpha theta y and yt minus yt bar. The right hand side is the same. Minus alpha theta pi, pi t minus pi t star plus epsilon t. Next one, I want to get rid of this term. I don't want it. So I just divide it for the whole equation. If I divide this term for the whole equation, I'm gonna get yt minus yt bar equal to minus alpha theta pi over 1 plus alpha theta y. Okay, pi t minus pi t star plus 1 over 1 plus alpha theta y epsilon t. This is what I have. Okay, and then I want to get rid of this one. It's quite big. Okay, here, this term, quite complicated. I'm gonna call it as A. And I also don't like this term, quite big. Okay? I'm gonna call it as B. Just change the name. Okay, call it as A and B. Then in the end, I got dynamic aggregate demand equation, which is equal to yt equal to yt bar minus A pi t minus pi t star plus B epsilon t. This is done. You see? And then I note behind the equation that A equal to alpha theta pi over 1 plus alpha theta y. B equal to 1 over 1 plus alpha theta y. Just note it like this. I copy this equation because I'm going to use this again. Now I can drawing the graph of dynamic aggregate demands. Drawing the graph here. Just like dynamic aggregate supply, On the horizontal is Y, but Y for the demand is about total spending. On the vertical is pi, inflation. Okay. Focus on the relationship between pi t and yt in the equation. If inflation become higher, everything become more expensive, right? The right-hand side become what? If pi become higher, in front of the bracket is minus. If inflation become higher, the right-hand side of the equation become lower, which means people gonna spend less. YT gonna be low. Left-hand side gonna be low. On the other hand, if pi t become lower, less inflation, everything is cheap, right? It means that it's less negative. Less negative is mean higher. The left-hand side is going to be higher too. If inflation is low, everything is cheap, people are gonna spend more. Make sense? This is actually law of demand, right? So then we can draw the graph. We're gonna have a negative slope like this. It's DAD. Always has a negative slope. Okay. Point A, if inflation is high, everything is expensive. People are gonna spend less. Point B, if inflation is low, everything becomes cheaper. People are gonna spend more. Easy. Got it? Then next one, we talk about the factor that's gonna shift the graph. Okay, I bring equation DAD equation here, dynamic aggregate demands, and then I'm gonna start drawing the graph here. Y on horizontal, pi on vertical. This is DAD1. Let's say we are here, point A. Inflation is here, pi 1. Total spending here, Y1. To focus on how to shift the graph, we're going to fix the level of inflation. If inflation is fixed over here, pi 1. Okay? The factor that can shift the graph is going to be pi star and demand shock, epsilon t. Focus on pi star first. For example, if I assume that today inflation is 4%, the inflation target, pi star is the inflation target. If the inflation target is 1%, what does it mean? What does it mean? It means that right now, everything is expensive because inflation is higher than target, 3%. If I increasing inflation target, okay, if central bank increasing inflation target, let's say from 1% to 3%, it means that people are going to change their thinking. Hey, inflation right now is not bad. It's just higher than the target, just 1%. It's not bad at all. Let's spend more. See, change the target. Okay, if the central bank change the target, people, the way people think is changing. Look at the equation. If inflation target increasing, in front of inflation target, pi star is minus. In front of the bracket is also minus. Minus and minus become plus, which means if inflation target become higher, people gonna spend more. The left-hand side gonna be increasing. Okay, spend more. Got it? Because when inflation target increasing, people gonna thinking that, hey, inflation today is not that bad. Higher than the target, just a small number. Let's spend more. Not only that, epsilon, demand shock. If demand shock increasing, the right-hand side of the equation increasing, the left-hand side also increasing. It means that we have some factor affect people to spend more. Like, for example, Christmas, New Year's, Chinese New Year, Thailand, we have Songkran. People keep spending during that day. All of this is going to make YT increasing, right? Total spending increasing, which means dynamic aggregate demand gonna shift to the right. Inflation still the same, moving from A to B, people spend more from Y1 to Y2. On the opposite way, if inflation target going down, we have a negative demand shock. It means that total spending gonna be reducing. Okay, the graph gonna shift to the left. Total spending decreasing from Y1 going to the left to Y3. Okay, this is the effect that gonna shift the dynamic aggregate demand curve. Clear? So we're done with dynamic aggregate demands and dynamic aggregate supply. Next one, we're gonna combine everything together. Okay. Starting with, we have dynamic aggregate demand equation. DAD, okay, YT equal to YT bar minus A pi T minus pi T star plus epsilon T. Okay. And then we have dynamic aggregate supply. Okay. Which means pi T equal to pi T minus 1 plus phi YT minus YT bar plus VT. Okay. Then, okay, let's draw the graph first. We have Y on horizontal. We have pi on vertical. We have dynamic aggregate demands, DAD at time t. We have dynamic aggregate supply, DAS at time t. And then I bring down the long run aggregate supply, LRAS. And then we're going to have equilibrium point here, right? I bring down LRAS because I want to see where is the Y bar, full employment level. Because in the long run, the economy is going to stay at full employment level, remember? So we have YT equal to YT bar over here. Okay, so now I can using the equation to explain what's going to happen in the graph. Let's start it with if we have a normal situation. Okay. A normal situation. For example, we don't have demand shock. We don't have supply shock. Okay. A normal situation. If we don't have demand shock, epsilon T equal to 0. If we don't have supply shock, VT equal to 0. Then they're going to rearranging the equation a little bit. Moving Y bar to the left, it's become YT minus YT bar equal to minus A pi T minus pi T star. Okay, I want you to focus on this one. Same thing with the AS. Okay, same thing with the AS. I moving pi T minus 1 to the left. It's become pi T minus 1 equal to V YT minus YT bar. Okay, here. Okay. I think I should share the color. Okay, it's a blue one. Then let's see. At the equilibrium point, YT equal to YT bar. Looking at the AD equation, YT equal to YT bar. The left-hand side of the equation equal to 0, which means the right-hand side supposed to be equal to 0 too, right? So it means that pi T inflation today is going to be equal to inflation target. You see that? DAS equation, if YT equal to YT bar, the right-hand side of the equation equal to 0, it means that the left-hand side supposed to be equal to 0 too. inflation today is going to be equal to inflation yesterday, stable. Which means at the equation point, at the equilibrium point, sorry, at the equilibrium point, YT equal to YT bar, then inflation also equal to inflation target. See? So the meaning of this graph, okay, it means that for the GDP is good, right? YT equal to YT bar, right? Which means GDP is okay, not too high, not too low, right? Normal situation. Same thing with the inflation. Okay, inflation here, high, also okay, not too high, not too low, equal to the target. When we say not too high or not too low, we compare to the target. GDP, when we say not too high or not too low, we compare to Y bar. Got it? Okay. So the meaning in the equation and the meaning in the graph support each other, confirm each other. And everything need to be making sense. So far, so good? Okay. And then we're going to use all of this knowledge, apply for 3 cases. And it's going to be in the exam for sure. 100%. Starting with case number 1. For example, if we have positive supply shock for 1 period, okay, only 1 period. I'm gonna starting with the graph, the big graph. On the horizontal is y, on the vertical is pi. This is DAD at time 0, the starting point time 0. DAS at time 0. I have long run aggregate supply here, LRAS, equilibrium point A. Y0 equal to Y bar. And pi 0 equal to pi T star. At time 0, everything is good. GDP equal to the full employment level. Inflation equal to inflation target. Everything is good at time 0, okay? Then I write down the DAD equation because I need to use it to explain. YT equal to YT bar minus A pi T minus pi T star plus B epsilon T. And I write down DAS equation. Dynamic aggregate supply, pi T equal to pi T minus 1 plus 3 YT minus YT bar plus VT. I'm going to copy this graph because we're going to have 2 more cases. Okay. The first case, this one, we have a positive supply shock. What is the meaning of that? Positive supply shock is mean that we have some external factor that make the cost of production in our country increasing. For example, we have a war, Ukraine, Russia. We have a war in the Middle East, Israel. For example, okay, the price of oil increasing, okay, and it's affect our country too, right? Okay, if we have positive supply shock, it's V. I put a yellow highlight on V. Okay, V increasing in the dynamic aggregate supply equation. The right-hand side of the equation increasing. It means the left-hand side also increasing, right? Okay. You can think about T is like year. Okay? In this case, T is like year. This is like 1 year. It's happened only 1 period. Happened only 1 year, just for example. Okay. So what happened in period 1? Period 1, VT increasing. Okay, cost of production increasing, everything become more expensive. Pi increasing, right? So it's affect dynamic aggregate supply. Dynamic aggregate supply shift up. This is the AS1. Dynamic aggregate demand still the same, comma 1. I put comma 1 behind DAD. Okay. Equilibrium point, of course, change from A to B. What happened? Everything become more expensive, pi 1. The economy slow down, y1. You see that? This is what happened. We have a conflict in the Middle East. Price of oil increasing, energy price increasing, it affects us. Cost of production increasing, then everything become more expensive. Inflation going up, economic slow down. Make sense? Okay. This is what happened in period 1. Again, this is the dynamic model. We have times in the model. Period 1, year 1. Year 1, this is what happened in year 1. Next, how about year 2? Year 2, the war over. The oil price go back to normal. No more supply shock. Year 2, no more supply shock. However, the economy still slow down, right? The economy in year 1 slow down. So what happened in year 2? We focus on the bracket Y minus Y bar in DAS, dynamic aggregate supply. Because of we have economic slowdown problem. Now I shade to the blue color. Y less than Y bar. See? We have economic slowdown problem. Y less than Y bar. In the dynamic aggregate supply equation, this bracket become negative. What does it mean? The right hand side going down. Economic slowdown, right? The right side going down. Then the left hand side, inflation need to be going down. And it should be make sense, because every time when the economy slow down, if you want to do the business, what you're going to do? When the economy slow down, you do the business. If you want to sell more, earn more money, you need to give people a discount, right? Every time the economy slow down, we're going to have a big discount. The price is going to going down. Inflation supposed to be going down. This is a price mechanism. Okay? Year 2, because of this, year 2, the price is going to going down, inflation going down. So dynamic aggregate supply shift down a little bit. This is point C. DAS2, demand still the same, comma 2. Equilibrium point C, the economy is still not good, right? If you point down below, inflation still high, GDP still lower than Y bar, economy still not good, right? Y still less than Y bar. From the equation, Y still less than Y bar. So which means the next period, year 3, what will happen year 3? Y still less than Y bar. The right hand side of the DAS equation is still lower. So it means that pi need to be lower. Okay? The economy is still not good. So you need to lower the price even more. Inflation become low. This is DAS3, point D, comma 3 on DAD. The economy is still not fully recovered. Next period, year 4, still going down. This is DAS4, point E, right? Still not good. Year 5, going down again. Go back to point A. In the end, inflation become lower, going back to pi star. GDP increasing until going back to Y bar. Fully recover in 5 years. See? Okay, this is a dynamic model. We have times. We can say how long it takes. Okay, this is just a graph. You are undergrad level, you just learning from the graph. If you study in master degree, you need to do the simulation. Calculate it in econometric, okay? Do the simulation. So you can calculate exactly how many years, how many days you need in order to go back to normal. But for you, undergrad level, just understand the graph is okay. Got it? Try to do opposite case by yourself at home. Fix on one period, but change from positive supply shock to negative supply shock. Negative supply shock is mean that you have a new technology, AI, computer, robot, right? And the cost of production lower. How it's going to be? Okay, you have to be able to explain it. This is case number 1. Next one, we go to case number 2. Okay, I go to the next page. Case number 2. If we have positive demand shock, okay, if we have positive demand shock for 4 period, okay, for 4 period, how it's going to be? Yeah. Okay. This one you can think about. You have a long holiday, Christmas, Thanksgiving, New Year's, or maybe Chinese holiday, or maybe Thai holiday, we call Songkran, water festival. Okay, long holiday for 4 days, let's say. How it's going to be, okay? We have positive demand shock. Where is it? It's here, epsilon T, in the DAD equation. During the long holiday, like a Christmas, like a Chinese holiday, like a Thailand New Year's, people are going to spend more. Having dinner together, buy a gift, okay, give a present to each other, okay? People spend more. Epsilon T increasing, this one, which make the right-hand side increasing. It means the left-hand side going to be increasing too. Total spending increasing, right? This one is going to make DAD shift to the right. This DAD day 1. That change from year to day. Okay? The period, 1 period is like 1 day. Day 1, DAD day 1. DAS still the same, 1. Okay. Equilibrium point change from A to B. What happened? The first day of the long holiday, the economy is very good, right? The first day of the long holiday, economy is very good because everyone going out shopping, eating, party. The economy is very good. Everything become more expensive, right? The economy is very good. Everything become more expensive. It makes sense, right? Okay. This is day 1. This is day 1. How about day 2? Day 2, people still spend a lot. Demand still here on the right. I put comma 2 over here because people still spend spend more than normal. Okay. Demand is on the right. How about dynamic aggregate supply? Now, the equilibrium point B, as you can see, Y greater than Y bar. The economy is very good. The economy is hot. Very good, right? People spend a lot, overspending. Y greater than Y bar. In the DAS equation, this bracket become positive. The right-hand side increasing, the left-hand side going to be increased, right? When economy is hot, when economy is very good, everything become more expensive. See? So DAS at day 2 start to shift up. This is DAS2. Equilibrium point here, point C. Day 3, still in a long holiday. People still overspending. Dynamic aggregate demand still here at day 3. Okay. Equilibrium point C, Y still greater than Y bar. Economy is still very good, right? From DAS, right hand side still increasing, left hand side also increasing, right? Everything become more expensive. This is DAS3, point D. Got it? Therefore, people still spend a lot the last day of the long holiday. DAD is here. I put comma 4. Okay. Economy is still very good, right? Everything still more expensive. DAS shift up. This is DAS 4, point E. During the long holiday, everything is expensive. This is very normal because people spend a lot, right? How about day 5? The long holiday is over. Go back to normal. Think about it. Go back to normal. Go back to work. What do you feel? Everyone feel sad, you know, after a long holiday, eating, drinking every day, going out, enjoy every day. And then Monday, you go back to work. You don't want to spend anymore, right? You don't want to spend anymore. Then exchange to the green color, okay? Demands going back to the left. It used to shift to the right. Now it's go back to the left. Go back to the normal demand curve, which is here. Go back here, the green color. Good. I put comma 5 here, day 5. How about dynamic aggregate supply? The equilibrium point E. Point E, Y is still greater than Y bar, right? Okay. So dynamic aggregate supply still shift up. This is DAS5. Okay, still shift up. However, demand already shift to the left. Where is the new equilibrium point? The new equilibrium point is on the left, point S. Here, to see that? Jump here, F. Economic slow down. You see? The first day after a long holiday, everyone go back to normal, go back to work, right? Stop spending the money. Economy slow down. Economy slow down. Then what else? Go back to DAS equation. Economy slow down. Y less than Y bar. The right-hand side of the equation become negative. Everything become cheaper. Dynamic aggregate supply shift down. F, G shift down. H shift down. I shift down. Back to A. You see? You see? Inflation back to normal. You see? GDP going back to the right, back to normal again, like a circle. This is how the economy adjusts themselves. Make sense? Make sense? Okay. Good. Try to do opposite case by yourself. Fix at 4 period, but change to negative demand shock. Think about it, negative demand shock, like a COVID-19. We have a lockdown policy, right? You cannot going out. Shopping mall closed, restaurant closed, nightclub closed. Okay, let's say 4 days, for example. How it's gonna be? It's the opposite case. Okay, done with case 2. This is very difficult to draw the graph, so you need to practice. Otherwise, you cannot draw it by hand. Okay? Try, practice, try to explain. Then we go to the last one, case number 3. Okay, if inflation target change, let's say lower inflation target down, lower pi star. Okay, lower pi star, which central bank can control inflation target. Okay, this is a job of central bank, the responsibility of central bank. Okay. Let me give you some numbers to make you more understand. For example, inflation target right now is 4%. And central bank lower the inflation target to 2%. Okay. So at time 0, everything is good. Inflation right now, 4%, equal to inflation target, which is equal to 4%. So at time 0, everything is okay, right? inflation is equal to the target. So it means that people are going to thinking that, okay, the price is not too expensive, it's not too cheap, equal to the target of the central bank. Everything is normal situation, right? And then one day, the central bank say that we should lower the inflation target down from 4 to 2%. Okay. So what happened? Look at the DAD equation. Inflation target is here, high star. We lower the inflation target down from 4 to 2%, which means right now inflation is 4, but inflation target is 2. So what does it mean? It means that right now inflation is too high, higher than target. Inflation is too high, higher than the new target, right? The bracket here is positive. In front of the bracket is negative, which means the right-hand side going to be lower. The left-hand side going to be lower. In the real meaning, they lower the inflation target down. It means that, hey, inflation right now is too high, higher than target. People going to rethinking, okay? Change their behavior. Hey, right now inflation is too high, higher than target 2%, which means everything is more expensive than normal. We should slow down our spending, right? Okay. So in this case, dynamic aggregate demand shift to the left. People slow down their spending. This is DAD times 1. DAS still the same because at equilibrium point A, everything is still normal. Okay, DAS still the same. The equilibrium point moving here from A to B. Okay, economic slowdown Y1. Okay, inflation going down high 1. Let's say inflation target from 4% going down to 2% somewhere here. Okay. Still good? Okay. And after that, the economy going to adjust themselves. Okay, at equilibrium point B. Okay, go to the next period, period 2. Okay, period 2. At equilibrium point B, Y, I change to the blue color. Y less than Y bar. Economy slow down, right? Y less than Y bar. This bracket is negative. The right-hand side of the DAS equation become lower. The left-hand side is going to be low. When economic slow down, business sector, they're going to lower the price. Inflation become low day by day. This is like day 2. Point C. Day 3. Point E. And then maybe too much. Day 4. Point F. And then last one, day, wait. Last one, day 5. G. Okay, 5. Now, at point G, inflation day 5 equal to the target. GDP going to the right equal to Y bar at point G. You see that? Okay. So it takes 5 days to go back to normal. Okay. And in the end, inflation lower until equal to the new target, 2%. This is how economy adjusts themselves. And again, you try opposite case by yourself. If inflation target increasing, how it's going to be. Okay. So today we're going to stop here. Done. And we're going to see each other again on Monday. Monday is going to be the last class. Good. Okay. Bye-bye.